Okay, so hello and welcome to this session. And as part of the previous video, we are going to continue this session of the decision tree classification. In our previous video, the decision tree algorithm, you might have come across the video. And in this session, I'm going to cover the same decision tree algorithm, but I'm going to cover two different type of uh, splits that can create a decision tree, or the decision tree can be constructed based on these two measures, that is the Gini index and the entropy. So decision tree algorithm is a most powerful and popular algorithm, and it has falls under the category of the supervised machine learning algorithm, and it also works best for the both the categorical output and the numerical as well. So the pseudocode for the decision tree algorithm is that first we need to find the best attribute and place it at the root node of the tree. Next, we need to split the training set of the dataset into different subsets, while making sure that each subset of the training data should have the same value for an attribute. That means that same value for a particular attribute. So we are splitting based on the criteria of the value from the attribute. Next, we split the leaf nodes, or we find all the leaf nodes, that is the target class variables, in all the branches by repeating the step 1 and 2 until we reach the final leaf nodes. So this is how decision tree algorithm works. And coming to the algorithm, uh, these are just the same code that is in the previous video. If you are not familiar with the previous video, I'll just post a link in the description, and you can go and check it out. So we are importing the required packages. We are just importing the data. This is a UC machine learning dataset. This is a UC machine learning dataset for balanced data, that is balanced scale data, and just printing the dataset shape and the length, that is the length and width of the that is the number of size of the data. And then we print the first 5 rows from the dataset in order to check whether the data is being read or not. So if I run this cell, this is just a function, so it can be called. Similarly, the same function that is discussed in the previous video, the split dataset, is used, and the same test size is fixed as 0.3, that is 30% for testing and the remaining 70 for training. And coming to the decision tree construction is based on two factors, the Gini index and the entropy. And the term Gini index actually means that it actually follows a formula that 1 minus sigma of ij square. So it means that it is a measure to refer how often a randomly chosen element would be incorrectly identified. It means that the lower the Gini value index should be preferred by the algorithm. So it is actually an impurity, and lower the Gini value means that there is lower impurity, and hence the classification will be much better, or much with higher accuracy. So sklearn, that is a scikit-learn, supports Gini criteria by taking the value, that is the uh, value for the algorithm as Gini. So next we can find the entropy, that is entropy based on the hx. For each the hx is actually used for finding out the entropy value of a particular element. So h of x is minus summation of I equal to 1 for all the n variables, and we find the probability of the variable with the help of p of xi and log p of xi. So this is how entropy is calculated. And suppose for example, if S is an instance and A is an attribute, so SV is the subset of the S and A is equal to B. So it means that the entropy changes as we use a node in the decision tree to partition the training datasets into a smaller subset. So information gain is a measure, so this which measures in the based on the entropy value, and sklearn supports entropy if we want to use the information gain method. So there are two functions that I have given here. The first one is the train using Gini. So this actually takes the xtrain, xtest, and ytrain. And as you can see, the decision tree classifier is created with the same criterion that is discussed in the previous video. So the classifier object is created and decision tree classifier with the criterion equal to Gini, and the rest of the parameters are all the same, and we fit the machine learning model with the training features and the labels, and then we return the trained model, trained decision tree model from this function. Similarly, there is another function that I have written for training using entropy. So for information gain, we are using the entropy method, and for Gini indexing, we use the Gini impurity. So this is the same code that is as given in the above, but instead there is a slight change there where the criterion is set to entropy. So this is the only thing that is differing from the two functions. So similarly, there is a prediction function. So this is the same function that is displayed in the previous video. So just uses the function, and it is used to predict the value, and it is displays all the predicted values. And then there is a calculation, that is a classification accuracy. And the only thing that is differs is here is that there is a report, that is a classification report, which displays all the precision recall F1 for all the actual and the predicted value. So this classification report, it is actually a Python module. So one second, let me just find it in the program. This is a classification report, and as you can see, it comes under the sklearn.metrics, and this classification report is used for predicting the classification of the decision tree algorithm. So it returns all the precision recall and F1 score of the trained decision tree model. So in the next phase, we are just building the data using the Gini index and the entropy. So this is just calling the functions that we have created, and as you can see, the data set and 5 rows, only top 5 rows is displayed using the head function, and the data set shape, that is the length, number of records is 625, and total number of total number of features are 5. That includes 4 features and 1 target class. Sorry. So in the next phase, we use an operation phase, that is we print using the Gini index. So as you can see, this prediction is made using the classifier for classification model for Gini, and we just display the calculated accuracy. And as you can see, the predicted values are displayed here. The actual values may be also be displayed using the same context. And as you can see, the confusion matrix is displayed, and accuracy is 73.40 percentage. And further, the precision recall F1 score and support is given for the weighted average. It shows the 68% precision and 73% recall and 71% score and 180 for support. So this is the results that we have achieved for Gini index. Similarly, in the next cell, the results for entropy is given here, and it just actually calls the same method. Only thing is that it is done using the predicted values of the entropy. So the classifier is also, the classification trained model is also following the classifier in entropy. And as you can see, the predicted value is given there, and the output is given at the bottom. So as you can see, it is 70.74 percentage, and the weighted average for all the 3 classes, the balanced, the left and the right, are all given as 0.66, that is 66 percentage, 71 percentage, and 68 percentage for precision recall F1 score respectively, and also the support is 188. So this is how the performance of the decision tree algorithm is varies from the type of measure that that we can use to construct the decision tree. So this is how the decision tree induction is being done. So these by following these two parameters, the decision tree induction can be made, and this actually covers the next part of the decision tree classification that is discussed in the previous video. And I hope you have understood the concepts very well, and if there are any more doubts, you can feel free to comment in the chat box, and please subscribe, share the video if you like it, and give it a like if you really think that we deserve the like. Okay, so thank you very much, and I'll see you in the next video. Thank you.